Heisenberg's uncertainty principle states that it is impossible to determine simultaneously the exact position and the exact momentum or velocity of an electron. And the mathematical representation of Heisenberg's uncertainty principle is given by delta x into delta p, which is greater than or equal to h by 4 pi. The same expression can be written as delta x into delta m Vx greater than or equal to h by 4 pi. Just by rearranging the same expression, it can be written as delta x into delta Vx, which is greater than or equal to h by 4 pi m, where delta x represents the uncertainty in position and delta px represents uncertainty in the momentum of the particle. If the position of electron is known with high degree of accuracy, its momentum cannot be predicted. Or if the momentum is known with high degree of accuracy, its position cannot be determined accurately. So this is what is Heisenberg's uncertainty principle. To observe an electron, we can use light or electromagnetic radiation having wavelength smaller than the dimensions of electron. The photons of light will have high momentum, which changes the energy of electrons by the collision. These collisions will change the velocity of electrons, and we can get very little information about the velocity of the electron after the collision. But the position of electron can be identified. But this experiment, in total, it does not give a very accurate information about the momentum, though we can identify the position of electron. Thus, the results of the experiment tend to be incomplete. So, what was the outcome of Heisenberg's uncertainty principle? That it rules out the existence of definite paths or trajectories for electrons and other similar particles. The trajectory of an object is determined by its position and by the velocity as well as other forces which are acting on that particular object. If we know the position, velocity of the object, we can fix its trajectory. Similarly, for the electron, if we can determine its position as well as velocity, only then we can fix a particular trajectory for an electron. Whereas with respect to electron, it's not possible for us to identify its position and velocity simultaneously. So, according to Heisenberg's uncertainty principle, we cannot fix a particular path or trajectory for an electron which is revolving around the nucleus. The effect of Heisenberg uncertainty principle is significant only for the motion of microscopic objects and is negligible for the motion of macroscopic objects.